Welcome to this first video for the Part A lecture notebook for the third module. This lecture notebook will discuss conditional comparison operators, meaning we'll be discussing logic and how to control workflow, and we'll also discuss functions. There will be 3 videos within this notebook. You should make sure to run this first line as we use NumPy, and we import it in the standard way as MP in this lecture notebook. If you don't run that, then some of the material later in the notebook will not run properly. So you'll notice that there's many activities actually within this notebook compared to some of our others, although many of these are quite short. So we'll just get right into it. This video will cover the first part of this lecture notebook, which is on conditionals and comparisons. The second video will discuss user-defined functions, and the third video will discuss something rather subtle about functions and variables and pass by value and pass by reference. So I've provided a link here to the official Python documentation that involves a tutorial on if statements and some basic loops, which is actually something we'll get to in the Part B lecture notebook for this third module. And I highly suggest that you go through parts of this tutorial on your own time and try to make your own notebook out of it. Make your own examples because you're really going to learn by doing some of your own experimentation and exploration. So without further ado, we'll start with conditionals. So by conditionals in Python, what we mean, typically speaking, are if, else if, where we use elif to mean else if, and else statements. So if, else if, else. Now the else if, the elif, and else statements are optional inside of the structure. You might only have an if condition, and if the condition is false, this will not run, and nothing would happen if you didn't have any other conditions. If you have an else if condition, that would only ever run if this condition for the if was false, in which case this condition would be checked to see if it was true or false. If it was true, whatever code was written here would then run. And if this condition was false, it would move on to the else condition. Now you can actually have multiple else if conditions, but we don't really get into too many examples of that right now. Now, an important thing to realize is all parts of the conditional are indented. We will see examples of this below. Python interprets everything in terms of indenting. This is something that you should read carefully and understand. And I'll point out in this documentation, the official documentation, you'll also know you'll notice the indenting is common. And here, by the way, is where they have 2 else if statements in that first example. And notice that they also have some, nesting of indents to group the code correctly. So it's worth looking over and running some of this yourself in another notebook, or even adding it to this one as part of your learning process. Now, we won't dwell on it too much. You're going to simply see how to do it in action, and you will get used to this, and it does make Python code actually fairly easy to read in terms of what parts of code are grouped together and are operated on depending on what conditions. Now, I show you comparison operators in order to describe how to create types of conditions that could be true or false and manage the workflow. So in this example that I show here, I discuss in text and then I have examples below it in code. I'm assuming that A is equal to 2 and B is equal to 3. Now notice there's a single equal sign because you use a single equal sign to assign a value to a variable. If you want to check if 2 values or 2 variables are the same, you would use 2 equal signs to check if A is equal to B. So these are 2 different things. If you wrote A equals B, you would be assigning B to the value of A, whereas this would check if A is equal to B. That is very important to remember. If you wanted to check if 2 things were not equal, you would use a exclamation point in front of the one equal sign, and that would check if 2 values are not equal. And then there's the standard greater, less than symbols. There's greater than or equal to, and less than or equal to. And then finally, we can use and, or, and not statements in order to also make more complicated conditions that we might want to work with in our workflow. So let's see some examples. And I do recommend trying to make your own comparisons that are not shown below. Make even your own variables, maybe C and D, and make them equal to some other numbers. and maybe even make them equal to some of the same numbers and play around with the conditions and see if you can guess, well, maybe make an educated guess as to what the output should be. And then if you're actually understanding things correctly, it should match the output. But I'll make here a equal 2 and b equal 3. Now, 2 is not equal to 3. So if I was to print the output of this operation, a equal to b, checking, this is basically checking, is a equal to b? It's going to return what's called a variable of type Boolean that is either true or false. And so if we look at this, of course it is false. 2 is not equal to 3. This is checking if 2 is not equal to 3, which of course is true. So that is true. So here's an example with the indenting where we can check an if condition. If a was equal to b, then we would print, hey, them two variables be equal. So there's some poor English there, but it's meant to be somewhat amusing. If I run this, notice there is no output because a is not equal to b, so it never ran that part of the code. It just simply moved on. There's no else conditions. There's no else if conditions. I just simply checked if a was equal to b. Now, if I made a new variable, like I'm encouraging you to do, and let's say it was c, and I made it c equal 2, and then if I checked if a was equal to c, hey, them two variables be equal. So these are things that you should do yourself to, again, develop some intuition and deeper understanding of how things work. But I'll go ahead and change that back there and get rid of this. There we go. All right. Now, a is equal to 2 and b is equal to 3. So a is not equal to b. So I'll fix my spacing there. And now I'll run this and it looks, hey, they ain't equal at all. Now notice, because I used an apostrophe in my string, that there is also a backslash in front of it, because the tick mark, the single tick mark, is a reserved character in strings in order to put all the text between it. So if I simply got rid of that, notice the change in color here. Look what would happen if I tried to run this. There's an invalid syntax. I get a syntax error. And that's because the string has ended, and yet I'm just putting the rest of this right next to it, and it just doesn't know how to interpret that at all. So if you want to have any like single tick marks, quote marks, and like reserved characters, it's kind of like using \n for a new line that we've seen before. I need to use a backslash and an apostrophe or single tick mark if I want an apostrophe to show up in the text that I'm printing out. So that's just a little thing that you're learning right here. Now here is how I can use comparison operators to create conditions in an if-else statement. So far I just had if statements. The else is completely optional, but sometimes you would want an else. So perhaps I want to check if two variables are equal. If they are, I'm going to print, hey, them two variables be equal. And then otherwise I'm going to say they ain't equal at all. So what should happen? Well, this condition we know is false. So this will not run, and then the else is just going to run if all the things above it are false. If all the other conditions in the if-else-if structure, and there is no else-if here, but if all those other conditions that preceded it were false, the else condition runs then by default. And we see that's exactly what happens because this is what ran. Now, it is worth noting that these colons that you see here are not optional. If I got rid of any one of these, like I got rid of that one, even though that's a false condition, this will produce an error. This is an invalid syntax, and it points exactly where the problem is. You need a colon to indicate the end of your if statement. Of your if, your else if statements, and your else statement. So for instance, if I got rid of it there, I would also get a syntax error, and it would be pointing right to the end of the else. So again, those colons are necessary. If I got rid of this indenting, this is also problematic because it expected an indented block. So now I'm getting an indentation error. And one thing to realize, so I'll just go ahead and delete this. I'm going to copy it out. If you were to press enter or return, whatever type of key you have to produce a new line when you're typing, notice that it positions it 4 spaces in. That's the common indenting in the Python community is 4. 1, 2, 3, 4. 1, 2, 3, 4. Now you can use other indenting, but it is not standard, and you will notice something change. Notice that this is now red. So if I did this, look what would happen. Everything ran, but it's printing in red because it's like this is an ugly way to write code. You're not conforming to the standards of the Python community, which is to use 4 spaces for every indent. Now, at the end of a line, for instance, if I was to add more things to the code, notice whenever I press return, that's what I'm doing on my keyboard, it's automatically indenting here because it's assuming I want to continue in that indent block. So this is somewhat problematic in some cases. So I'm going to get rid of this real quick and show you why. Imagine that I wanted to start writing the else command, right? So imagine that I'd written this part of my logic so far. And then I said, I want to write the else command. And then this is just a test. Watch what will happen here. This is an invalid syntax because it's saying, well, else what? Because it thinks that there should be an if and an else maybe within this statement, but it's not connected to that if because its indentation is not aligned with it. So the point of this is if you're here and you want to use an else, press the backspace and it will say, oh, I will re-indent and realign it with the previous level of indenting, which is right here. And so I'll just put that code back to fix it. So you should get used to this over time, and you'll often encounter errors and notice the color of font being red to indicate that you're having some things that it's not that they will not run and you won't necessarily get errors, but it's not what you should do. You should try to conform to the standards, and actually it's trying to help you conform to the standards of what the spacing looks like. So then there's some other commands here as well. Just to print like is A greater than B, of course that's also false. And then things with ors, ands, and nots, which was what I discussed up above in terms of using and or statements that allows you to combine sets of comparison operators. And the not statement negates a statement, meaning it turns a false to a true and a true to a false. So 2 is not greater than 3. So, to ask, is 2 greater than 3? Well, that is false. Is 2 greater than 3 or is 2 not equal to 3? Well, this statement is true, but this statement is false. What do you think it should be if you have a false or a true? Well, the answer should be true. If you are connecting statements with an or, you only need one of the statements to be true in order for the entire statement to be true. It is not both statements could be true as well. It's not an exclusive or. Now, an and requires that both statements be true. So this statement is false, this statement is true, and so is this if a false and a true is false. But then the not, and notice the parentheses here, not A greater than B and A not equal to B, well now this will be true and this will be true, so the output of that should be true. There you go. And now I'm showing some examples of if-else-if statements. So here I'm checking if A is greater than B. If it is, I print that A is greater than B. Else if A is less than B, I print A is less than B. And then what's the only other thing that could happen? Well, otherwise, they would be equal. They'd be equal. So, well, here A is less than B. We know that to be true. Now, if I go back and change B to be 2, so now A and 2 are the same. So here, before that was false, so this part of the code did not run, but this part of the code, this condition was true, so this part of the code ran. Now I'm making both of these conditions false, so that means that this part of the code should run. And we see that it does. So now, I'll just leave that for now. Here's another example of a nested set of if-else-if statements, and I want you to pay attention to the indenting. So if A is greater than or equal to B, then I go and check if A is strictly greater than B, in which case I print that A is greater than B, and if it wasn't, then I know that it was actually equal to B, so then this part of the code should run. Otherwise, else, the only other option is A is less than B, and that's what I print. So here, this part of the code should run just like before, except that it occurs in a different part of the code, and notice how it's indented. This if-else block is indented within here. And if you had really complicated sets of conditions to run, you might have many nested if-else-if type statements, And you can nest these things further. Maybe within these, you nest them even more, especially if you try to create your own variables. Like I'm suggesting, you try to make it a more complicated example to see how well you understand it, if you can understand what the outputs are. And then go back and change what the values are and see. So now if A is equal to 2 and B is equal to 3, none of this code should run at all because A is not greater than or equal to B. A is less than B. So now this part of the code should run where it's A is less than B. And that's exactly what happens. So that is kind of the end of the first part of this notebook involving comparisons and controlling workflow. And you have two activities before we get into user-defined functions, and I'll have another video for that part of the lecture. Now, for these two activities, let's read these instructions carefully. The code below, this code cell right here, notice I'm using the NumPy, so you better have imported NumPy as NP. We're trying to evaluate the function f of x equals the square root of x divided by the product of x minus 2 and x minus 3, which is in the denominator. Now, this is only valid if we're trying to produce real values out of this function. We need x values that are greater than or equal to 0, but they also need to avoid values of 2 or 3 so that we don't divide by 0. So we don't want to take square roots of negative numbers, and we don't want to divide by 0. So the first thing I ask you to do is try changing different values of x in the code below to see what happens. So notice, let's first of all look at these conditions. The first one is if x is greater than or equal to 0 and it is not equal to 2 or equal to 3. So if x is greater than or equal to 0 and it's not 2 and it's not 3, then all of a sudden I evaluate the function. I assign f the value that is the square root of x. I'm using the power function within NumPy to raise x to the 0.5 power. That's the same thing as taking the square root. And then I divide, look at the parentheses, by x minus 2 times x minus 3, and because I put both that product in parentheses to divide by that total product. If you got rid of that, and some students will do that occasionally if they're writing it, this is wrong. This would divide by x minus 2, but then it would multiply this entire part right here. Let me try to highlight it. There we go. It would multiply that by x minus 3. So that's not what we want. We want to divide by the product of x minus 2 and x minus 3. Again, look at this function. So it is correctly written there. And if I try it with x equals 3, watch what will happen. Nothing. Nothing's printed to screen. Well, x is equal to 3. So this part right here, let's go through the logic. Is x greater than or equal to 0? Yes, this is true. But x is equal to 3. So this is true because it's connected with an OR statement to the x equals 2. So true or false, well, that gives us true as a total, but not true would give us false. So we have a true and a false. Notice the not is around with these parentheses is connected to this whole thing there. That OR statement is the entire OR statement is negated. So this is false. So this never ran. So f was never assigned a value. And then it went and checked to see if x was less than 0, which is also not true. And so nothing happened. And so this is part of the issue. You could try running also with x equals 2. Nothing happens. Try it with x equals 0. Oops, that is an incorrect way to write it. There we go. Well, 0 works. The square root of 0 is 0, and it's divided by a non-zero number, so it gives you 0. If I try 1, that works. If I try a negative number, let's say -1, I'm informed that I'm trying to take the square root of negative number, and then I assign to f not a number. That's what the NaN variable is in NumPy. It is not a number. So with this discovery of playing around with these different x values, we realize this code is missing a control for the case where x is a value of 2 or 3. What happens when it's 2 or 3? Well, we want to print something to the screen and assign not a number to f. What should we print? I suggest that you print to screen that you are trying to divide by 0. So here it says square root of negative number, and then you might run a print attempting to divide by 0 and then assign f to a not a number. The question is how you should incorporate that within the logical workflow. There's actually several ways. I suggest you try at least 2 ways. Try to think of 2 ways. You only need to do one. It's only required that you do one. But I highly suggest you think of 2 different ways that you can control for the cases when x is 2 or 3. What happens when either of those things happen? How should you control it? There's multiple ways you could do that. And what you should do is then print some useful feedback to the screen, such as trying to divide by 0, and then assign f to not a number, so that f is always assigned something no matter what value of x is given, and some useful thing is printed to the screen, either the value of f or information about why f was assigned not a number. Now for coding a tent function, you're to complete the code below, which is in this cell. It's not completed. It's missing an else if condition. Notice there's no condition there. You need to provide it a condition so that it properly is evaluated, and then test with different values of x to make sure it works. That's all you have to do here, is you basically have to fill in this condition correctly, and I'll be looking to see that you did that. If you look, why do I call it a tent function? Plot it by hand, and you'll see that it looks very much like a tent. It's 0 up until x is -1, and then it linearly increases up to 1 from -1 to 0. Then it linearly decreases down to 0 as x increases from 0 to 1, and then it stays at 0. It's 0 otherwise. It's only non-zero in these intervals. So we see if x is greater than or equal to -1 and x is less than or equal to 0. Now I wrote it like this, but I would highly recommend when you're combining conditions with an and statement to use parentheses, so that it's very readable and understandable about what the individual conditions are that you're combining. And then, because sometimes it happens, for instance, like up here, where I combine 2 statements and I put parentheses around it. It's not necessary, but sometimes it helps with the readability. So here, you might also want to add parentheses around either of these. It kind of is, in some sense, up to you, as long as it's logically correct in what you want. You want to make sure that it's also readable and understandable as you start to investigate it. I think this looks a little better without the inner set of parentheses, and this one I think looks better with the parentheses, but I'll actually leave it off because it's a stylistic choice and it's up to you. I encourage it. Do it however you want though, as long as it works, but you should have a style that's consistent across your work. So that's pretty much it for this first part of the lecture notebook. Thank you for listening, and I'll talk to you in the next one where we discuss functions in Python.